Okay guys, next section, 9.2 and 9.3. Here's the vocab. And this should all look familiar to you from last year. It's the sum and difference and double angle identities. So the first one we're going to do is the sum and difference of sine, cosine, and tangent. And if you remember, there's two of them. Basically, if you have the sum, so sine of an alpha plus a beta, you are able to break this down: sine of alpha cosine of beta plus cosine of alpha and sine of beta. Okay, and if you have the minus, then you have sine of alpha minus beta, and it's basically the same exact thing except sine of alpha cosine of beta minus cosine of alpha sine of beta. So that's for sine, plus or minus. So basically you can look at it as you are able to break this up or bring it back together. The pluses and the minuses stay the same in the center, and then the alpha and the beta get switched around with sine and cosine. Alright, next up, for cosine, you also have the plus and the minus, so cosine of alpha plus beta, and then of course cosine of alpha minus beta. Now remember last year I used, what was it, Costella and Sinbad. So remember we said that Sinbad is going on a double date, right? So if the guy is explaining the date, then he's going to say, oh, we're going to sit guy and girl, guy and girl. But if the girl is explaining the date, or Costella, then she would rather sit with her girlfriend rather than sitting with the guy. I know this is funny, but I remember last year that helps you guys remember things. So sine of alpha, sine of beta. So you notice here that the cosines are together, the sines are together, but you also notice that with cosine the sign does change. So if it's positive originally, it becomes a negative. And if it's negative originally, of course, it's going to become positive. Alright, now tangent is a little bit different. So basically with tangent, you have either the plus, so tan of alpha plus beta, and this one is written down as tan of alpha plus tan of beta over 1 minus tan of alpha tan of beta. And then if you have the minus, so tan of alpha minus beta, then this one is basically tan of alpha minus tan of beta over 1 plus tan of alpha tan of beta. Alright, so that is the sum and difference identities, and you'll see why we can use these, because basically the whole idea is if you spot this, you can clean it up. Or if you can't add the alpha and beta easily, then you can break it up and just figure out what is sine of this guy and cosine of this guy, numerical values, and then solve it like that. And we'll do examples in class. Alright, now here are the double angle identities. Again, we did these last year. Now cosine has 3 double angle identities. And we'll talk about it tomorrow in class, how they're all basically the same thing, just written in different ways. So the first one is you can break up cosine of 2 times theta, so 2 times the angle, into cosine squared of theta minus sine squared of theta. another way to break it up is to say 2 cosine squared theta minus 1, and then or 1 minus 2 sine squared theta. And we'll show the proofs of this in class. Now, sine of 2 theta is pretty easy. It's just 2 sine of theta cosine of theta, and that's the only one that is there. Okay, so now that you have your identities for sum, difference, and double angle to add on to the fundamental identities that you guys took a quiz on today, you'll see why this is important in just a second. Now, the example that is provided in the notes is for tangent of 2 theta. So we use this to basically explain why tangent of 2 theta ends up equaling this. So tangent of 2 theta is the same thing as saying tangent of theta plus theta, correct? We have 2 theta. And now this right here is basically what? It's the sum identity of tangent. So let's remember, what was the sum identity of tangent? The sum identity of tangent is just tangent of theta plus tangent of theta over 1 minus tangent of theta, tangent of theta. So this ends up equaling tangent, whatever our alpha is, which in this case is just theta, plus tangent, whatever our beta is, which in this case is theta, over 1 minus tangent of alpha, which in this case is theta, and times tangent of beta, which in this case is theta. So if you continue to combine these, what do you end up with? Here we have 2 tan thetas, combine like terms, and down here we have 1 minus, these are multiplied, so it's tan squared theta, which proves the double angle. Using the sum identity, we proved the double angle identity. Alright, so I'm going to do just one example of what we're going to do tomorrow in class, or maybe 2. We'll do 2. So here's the idea. On page 694, we're going to complete the majority of these in class together tomorrow, and I want to start with them. So let's start with number 6. Number 6 in the textbook gives you tan of pi over 12, and it asks, what does it equal? Okay, so it asks, what does it equal? So basically, tan of pi over 12 is obviously not on the unit circle. It's not an easy point to figure out on the unit circle. So what we do is we're going to use either the double angle identity or the sum and difference identity to break this up into 2 parts that are on the unit circle. Okay? So now, basically what I want to do is I want to split tan pi over 12 into 2 parts that are on the, I don't know, I think it's that periodic table, but on the unit circle. Alright? So pi over 12, let's split it up. So if you split it up, you need to think of basically 2 points. The easiest way to split these up is to keep the denominators the same for a minute. And then to get pi, what can you do? What 2 numbers? So you know that there's pi up top. But to get a single pi, what 2 numbers, what operation can you do? You can do 2 minus 1. Okay, so we can do 2 minus 1. We can do 4 minus 3. And here I'll tell you why in a second, why both of those would be just fine. So if I do 4 minus 3, because there's obviously no way to add to get a single pi. And we don't want negatives, okay? You don't want to deal with negatives. So that's why I'm using subtraction. And now so 4 pi minus 3 pi over, both of them over 12 equals pi over 12. But I'm not going to put them in like this because 4 over 12 can simplify down into pi over 3 minus 3 over 12, which is pi over 4. So what I just did is I just split pi over 12 into two of the radians that are directly on the unit circle. So here we have pi over 3 minus pi over 4. And the reason that this is important is because we just used the difference of tangent to split them up. And now that I know what the identity for the difference of tangent is, which is tan of alpha, which in this case, if you remember, this guy is my alpha and this guy is my beta. Because there's a minus here, so for the tangent identity, it's going to be minus tan of my beta. All of that is over 1 plus tan of alpha and tan of beta. And now I just replace. I know what tangent of pi over 3 is. Based on the unit circle, let me find my unit circles. I might have thrown them out. There we go. So based on my unit circles, here's pi over 3, and if we remember, tangent is just sine over cosine, so it's going to be y over x, right? So y is the square root of 3 over 2, all of that over 1 over 2. Flip the guy and multiply, right? So this becomes times 2 over 1. The 2's cancel out, so we're left with square root of 3. So tangent of pi over 3 is just square root of 3 minus tangent of pi over 4. Where's pi over 4? Right there. Tangent of pi over 4 is y over x, which is just 1, so it's just minus 1, over 1 plus, we've already figured out tangent of pi over 3, it's square root of 3, times tangent of pi over 4, which is 1. And now we just continue to simplify this. Okay, so right now we have square root of 3 minus 1 over 1 plus square root of 3. But of course we can't have a rational in the denominator, a radical, sorry, in the denominator, so we rationalize the denominator. And because there's two terms, we multiply by the complex conjugate. Sorry about that. So it's 1 minus square root of 3 over 1 minus square root of 3. So now when we multiply this out, first, right, this is still a binomial times a binomial. So first the square root of 3, outer ends up being minus 3, inner is minus 1, last is plus square root of 3. All of that is over first 1, outer is minus square root of 3, inner is plus square root of 3, and last is minus 3. Continue to clean this up. So square root of 3 plus square root of 3 is 2 square root of 3. Minus 3 minus 1 becomes minus 4. All of that over 1 minus 3, which is negative 2. And I can still clean this up because in these terms you notice that there's a factor of 2 already in all of them. So if I factor out a 2 and I'm left with square root of 3 minus 2, all of that over negative 2, what happens to the 2's? They're gone. So we're just left with a final answer of square root of 3 minus 2. So tangent of pi over 12 is equivalent to negative square root of 3 minus 2. So without a calculator, I took a radian that was not on the unit circle, split it up into two radians that are on the unit circle using the difference identity, and I use that to solve. Alright, so that's basically what we're going to be doing tomorrow. So I want you guys to at least have up to number 6 done, and then tomorrow we'll do the rest of these together in class. Okay? With including some homework assignments. Alright, enjoy.